So before I solve these two problems, these are the two equations that are not on the crib sheet that I'm going to provide with a test. You have to have these. These are the relative velocity and acceleration equations with rotating frames. So let me explain what's going on here. So you'll have a point C here. You'll have a point D here with some kind of a slot, and then D is sliding along a slot while C is rotating. Okay, so C is rotating with omega and omega dot, or alpha. Okay, so what this says is that the velocity of D is the velocity of C, and normally we have D relative to C, but because it's rotating, we have a couple things. So this right here, this term, that just means D spinning around C. And so what that is, the velocity of D spinning around C is just this, 90 degrees omega times R. Okay? This here is VD relative to C in the local rotating frame. That's just a fancy way of saying that's what the camera sees, if you remember the videos. So we had that Godzilla on the skateboard, we had the camera in the middle of the plate, and then we just saw that Godzilla sliding in towards the center. Okay, so very similarly, we have the same equations for acceleration. So the acceleration of D is the acceleration of C plus, we want all the stuff D relative to C, but it's complicated by the fact that it's a rotating frame with the sliding. So this term right here is just D spinning around C, but acceleration, not velocity. And so what you need to remember from what we did in class, I had that popsicle stick. There's an acceleration coming in of R omega squared, and there's an acceleration going that way of R times alpha, but instead of alpha, we're saying omega dot, but it's the same thing. So that's what those two things are. This term here is what the camera sees. Okay, so the acceleration of that Godzilla on the skateboard coming in towards the camera. So that leaves this term here, which is the strange Coriolis acceleration. It's 2 omega times that V sliding that you get from the velocity equation. Okay, and so that follows the right-hand rule, so I'm going to draw it down here. So let's say omega was this way, and let's say the V relative was that way, and I can't show you, but using the right-hand rule, omega cross V would be this way. That would be 2 omega cross V relative. Okay, so we'll be using both of these equations in both of the examples to come. So I decided to work both the Work It Wednesday problems as a review. So